Hello everyone, welcome back to SNDev, and in today's video we'll be seeing Convolutional Neural Networks or CNN in TensorFlow. Okay, so before getting into the code, let us ask that what is CNN, right? So a CNN is a type of deep neural network designed for processing structured grid data like images, right? Because images are formed in pixels, and it's widely used in tasks like object detection, image classification, and medical image analysis. Okay, and the kind of what would say, like the key components of CNN would be like convolutional layers, pooling layers, and fully connected layers. So if I show you with a diagram, you would see that if this is the workflow of a CNN, so this is the image, like the input data that will be giving an RGB image. Then we have two layers. So one is convolutional layers that mainly extract the features from an image. Okay, then after extracting those features, those fade into an pooling layer with the consist of 2 into 2 stride. Okay, and what these strides mean, these strides reduce the spatial dimensions while retaining essential features, because in a, let's say in a 20x20 image pixel, not all the pixels are important, right? So we might have to extract the main pixel columns or the main pixel values from there. So that helps us by these pooling layers. Okay, so we have this convolutional 2D layer, then we have this max pooling layer. Then after all of this, we flatten all of these images, and then we fade this into an hidden layers with the ReLU function, and then from the output layer with the softmax, we predict our output value. Okay, so this is the basic structure of our CNN. So, and in this problem we'll be solving an image classification using CIFAR-10 dataset that contains more than 60,000 images across 10 different categories like airplanes, cars, birds, cats, and more. So our goal would be to train a CNN model to correctly classify these images using TensorFlow and Keras. Right? So let's begin. Okay, so first we have import necessary packages. Let's do it. So our packages would be TensorFlow HDF, then from TensorFlow you need to import Keras because Keras comes with TensorFlow, right? Then of course NumPy for basic mathematical, then to plot, as PLT. Okay, now we need to load it. For load, what we will do in our, we'll load the dataset into X-train, Y-train. Okay, not here. Right. So X-train, Y-train, X-test, Y-test, and here I'll need to load my data. So datasets dot CIFAR-10 dot load data. Okay, then also I need, okay, let's run this cell first, then we'll be pre-processing it. So we have downloaded all data, right? Okay, now we need to pre-process. So for pre-process, we simply need to normalize the values, right? So for normalizing the values, what we'll be doing, we'll divide X-train and Y-test with 255. With 255, okay. Alright, now it's time to build our CNN model. It will be pretty easy to build as we have shown in the diagram. So in model, I'll be naming my sequential. Here I need to build the model, right? So first Keras dot layers, then for the convolution layer we'll be using conv 2D, then we'll use 32 comma 3 comma 3. Activation, of course, we'll be using our ReLU, and in input shape the input images should be with the pixel size of 32 into 32 into 3. Okay, then Keras dot layers dot max pooling with the stride of 2 into 2. 32, okay, it will be only 1 comma. Alright, so what I'll be doing, I'll be just simply copy this 2 line and I'll paste it here. I'll be doing it with, let's say, 64. So 64 3 activation function, but this is not an input layer, right? So I don't need this input shape, but for pooling I'll be using that. And again, for the last one I'll be simply using my convolution, but this time I'll be using with 128. Also I need to delete the input shape. Okay, now I'll be using that flatten layer. So layer dot Keras dot layers dot simply I need to flatten the data, then Keras dot layers dot for the hidden layers 128 neurons with the activation function of ReLU. Then for the output layers we have to use 10 neuron with activation function of softmax. Alright, let's run the model. Okay, there will be some error. Keras layers max pooling. Acha, yeah, the max pooling have to be in the 2D form. So 2D. Okay, done. Right, now we need to compile the model. For compile, it will be as simple as other neural network syntaxes. So simply we need to compile. The compiling, we need to provide an optimizer. Let's say I'll be naming it Adam. After Adam, I need to provide it the loss. For loss, I'll be using sparse categorical because it has multiple category. So mask sparse categorical cross entropy. Okay. It's entropy, then matrix should be of accuracy. Let's run it. So we have compiled our model. Okay. Okay, now it's time to train our model. So for the training, we'll use this history variable. Here we'll call our model.fit function. .fit xtrain comma ytrain with epochs of 10, and for the validation data I'll be using xtest and ytest, and it will be, So let's run this. So it will take some time because it will run this whole model 10 times. So let us run it. Okay, it's using my GPU a bit now. Okay. Okay, so let's also write the function for the evaluation, right? For the evaluation, what we'll be doing will be our test losses and test accuracy, and we'll simply call our evaluate function and we'll pass x test and y test with verbose of 2, and then at last I simply print that test accuracy is around test SCC. Okay, so now as you see that our accuracy is touching around 80% for the training set and around 68% for the testing set, which is not really good because we haven't run it for the big epochs. We have only done for 10 epochs. We might have to run it for 20, 30, or we can just modify the structure a bit for a better result. So we are done with it. Now let's run this evaluation function. So you see the accuracy for the testing accuracy is 67%, which is of course not good at all. Now let's test the model, right? So for testing, we'll test onto some random data. So we'll create some pixel. So let's say randint 0 with test -1 prediction model dot predict np dot expand the dimension. Here I need to pass my x test with that particular index value with axis of 0. Okay, then simply plot IM show. I need to pass that x test with that index, then plot dot show, and for the final let's print the prediction label. The prediction label, let's say it would be prediction label, let's take it as np dot argmax. Here I'll call my prediction. Let's run it. So yeah, prediction level 8. So yeah, that's the thing. Of course it haven't really predicted properly. So you have it. Our CNN model successfully classified the image from the CIFAR-10 dataset. So if you found this video helpful, like and subscribe. So yeah, thanks for watching.